Good evening, sir. My name is Geeta Mahalakshmi. Today I am here to explain about microservice architecture. First of all, what is microservice architecture? Microservice architecture is an approach to building a service application as a set of small servers. That means a microservice architecture is mainly oriented to backend, although the approach is also being used for the front end. Each service runs its own process and communicated with others. Crossing unit protocols such as HTTP or HTTPS, WebSocket or AMQP. Each microservice implemented a specific end-to-end domain or business capability within a certain context boundary, and each must be developed autonomously and be developed independently. Finally, each microservice should own its related domain, data model and data logic sovereignty and decentralized data management and could be based on different data storage technologies such as SQL, NoSQL, and different programming languages. Then what should size microservices be? When developing a microservice, size shouldn't be important point. Instead, the important point should be to create loosely coupled services so you can have autonomy of development and scale for each services. Of course, when identifying and designing microservices, you should try to make them as small as possible, as long you don't have to many direct dependencies which other microservices. Most important than the size of the microservice is the initial cohesion. It must be independent for other services. What is microservice architecture? In short, it provides long-term agility. Microservices can better maintainability in complex, large, and high security systems by letting you create applications based on many independently developable services that each have granular and autonomous life cycles. As an additional benefit, microservices can scale out independently instead of having a single monolithic application that you must scale on unit. You can instead scale out of specific microservices. That's why you can scale just for the functional area that needs more processing power or network bandwidth to support demand rather than scaling out of areas of the application that don't need the scaling. That means cost saving because of you need less hardware. Here are the brief information about monolithic development approach and microservices development approach. A traditional application, first of all, monolithic development approach means a traditional approach has most of its functionality within a few processes that are compiled with layers and libraries. Scales by cloning the app on multi-servers. Courses gain a density of apps or services. Need the develop that fully application. The brief information about microservice application approach. A microservice application secretes functionality into separate smaller systems like app 1, app 2. Scales out by developing each services independently with multiple instances across services or VMS. Independent development of microservice. Fine-grained density of microservice. Methodology development versus the microservice approach. As a figure shows that in the traditional monolithic approach, the application scales by cloning the whole app in server services or VM. In microservices approach, functionality is segregated in small services, so each service can scale independently. The micro approach allows agile changes and rapid irrigation of each microservices because we can change specific and small areas of complex, large, and scalable applications. Architecture fine-grained microservices based applications enables continuously integration and continuous delivery practices. It also accelerates delivery of new functions into the application. Fine-grained composition of applications also allowed you to run and test the microservice in isolation and evolve the autonomously by maintaining clear constraints between them. As long as you don't change the interfaces or constraints, you change the internal implementations of any microservices or you add new functionalities without breaking other microservices. The following are important aspects to enable success in going into production with a microservices based system. First of all, monitoring and health checks of service and infrastructure, scalable infrastructure for the services that is cloud and Astra structures. Services design and implementation at multi levels, authorization, secrets, management, secure, communication, etc. Rapid applications delivery, usually with the different teams focusing on different microservices. In this, we briefly introduction about what is microservice architecture, advantages of microservice architecture, key concepts of microservice architecture, challenges of microservice architecture, best practices of microservice architecture, real world examples of microservice architecture. First of all, what is microservice architecture? Microservice architecture is an approach to software development where a single application is broken down into a collection of loosely coupled independently developable services. Each service has its own set of functionalities and can communicate with other services through APIs. And then advantages of microservice architecture. Microservice architecture offers several advantages over traditional monolithic architecture. Some of the key advantages include scalable, resilience, examples of brief introduction of scalability. Scalability means microservices can be scaled independently, allowing organizations to handle increased traffic and demand without affecting other parts of the system. Resilience. Resilience means if one microservices fails, it doesn't necessarily bring down the entire system. The rest of the services can continue the function without interpretation. Agility means microservices are easier to develop, test, and deploy, allowing organizations to quickly respond to changing business requirements and market conditions. Technology diversity. Technology diversity means different microservices can be built using different technologies, allowing organizations to use the best tool for the job. Improved reliability. Microservices are easily to monitor, debug, and troubleshoot, making it easier to maintain the overall system. Better collaboration. Better collaboration means microservices enables team to work independently and make changes to their services without interfering with the work of the other teams. Key concepts of the microservice architecture. Microservice architecture is based on several key concepts such as service. Service means each microservice architecture should have a specific set of functionalities and should be designed to do one thing well. Decentralized data management means each microservice should manage its own data and should not rely on other services to manage its data. API driven. API driven means microservices should communicate with each other through well-defined APIs. Independent development. Each microservices should be independent developable without affecting other parts of the system. Continuous delivery. Continuous delivery is the crucial to microservice architecture. Each microservice should be tested and developed independently for other services. Develops. Develops is an essential part of the microservice architecture. Teams responsible for each microservice should be able to manage the services throughout the entire life. Challenges of microservice architecture. While microservice architecture offers many benefits, it also comes with some challenges. Some of the key challenges include increased complexity, distributed systems, such that increased complexity means microservice requires a more complex infrastructure, including additional services, load balance, and other tools. Distributed systems. Distributed system means microservices are distributed systems which can lead to issue with the network latency. Services discovery and data consistency. Testing. Testing means testing become more challenging in microservice architecture. As such, microservice must be tested independently as well as combined with services. Data management. Managing data across multiple microservices can be challenging as data continuously and availability must be maintained across all services. Best practice of microservice architecture. To overcome these challenges, ensure success with microservices architecture, it's important to follow some best practice, including choose the right technology and use API gateways and implementing service discovery, implementing circuit breaker, use set contaminations. The brief introduction about best practices of microservice architecture. First of all, first choose the right technologies. Select the right technologies for each microservice and ensure that they are compatible with other service in its architecture. Use API gateway. Use an API gateway to manage API requests and response between the microservice. Implement service discovery. Implement a service discovery mechanism to ensure that service can discover and communicate with each other. Implement circuit breaker. Implement circuit breaker pattern to improve the redundancies of the system. Microserver architecture is a modern approach to software development that structures an application as a collection of small and independent and loosely coupled services that communicate with each other over well-defined APIs. Each server is designed to perform a specific functions or task and can be developed and scaled independently of the other services. In microserver architecture, each server is built around a specific business capability such as user authorization, payment, processing, or product recommendations. Services communicate with each other using lightweight protocols such as REST or message queries and can be developed into programming languages with different data storage technologies. Microservice architecture offers several benefits, including scalability, flexibility, and fault tolerance, as well as the ability to develop and release new features and updates more quickly and more independently. However, it also requires careful design, testing, and management to ensure the services and communicate effectively and that overall system remains reliable and secure. Microservice architecture, often shortened to be microservices, refers to an architecture style for developing applications. Microservice architecture allows a large application to be separated into smaller independent parts, with each part having its own realm of responsibilities to a single user request. A microservice based on application can tell many internal microservices to compose its response. Within a microserver architecture, each microserver is a single service built to accommodate an application future. First of all, what is microservices used to, when it will be used, and how? Typically, microservices are used to speed up the application development. Microservices architecture built using Java and Common, especially Spring Boot ones. It also common to compare microservices versus service-oriented architecture. Both have the same objective, which is to break up the monolithic applications into smaller components, but they have different approaches. Here are some microservice architecture examples. Website migration. A complex website that hosted on a monolithic platform can be migrated to a cloud-based and container-based microservice platform. Media content. Using microservice architecture, images and videos assets can be stored in a scalable object storage, such as service directly to a web or mobile. Transition and invoice. Payment processing and ordering can be separated as independent units of the service. So payments continue to be adopted in invoice is not working. Data processing. A microservice platform can extend but supports for extending model data for the process. This is the brief introduction about microservice architecture. Thank you.